I'm sure you've heard of Stegosaurus. Everybody's heard of Stegosaurus. That's the big cumbersome thing that had pachyderm-like legs. A hunchback with tiny little minuscule head, but most importantly in the way you recognize it is by the fact that it had double row of great, big, bony, triangular plates running the length of its back, and its tail was tipped in for very long spikes. It was a strange looking creature, and it's one that most kids learn about when they first start learning about dinosaurs. One of the funny things about Stegosaurus is, that when scientists first looked at its skull, they realized that this creature, that weighed maybe 2 tons, had a brain about the size of a walnut, and then when they looked at its backbone they found that, in the area where hips are, the nerve cord seemed to get larger. It was as though it had a second brain. Second brain at its hip. That's what led to the bone, so let me read the poem for you. It's about the 2 brains of the Stegosaurus, written by Berteleston Taylor in the year 1911. Behold the mighty dinosaur, famous in prehistoric lore not only for his weight and strength, but also for his intellectual length. You will observe from his remains, the creature had 2 sets of brains, one in his head, the usual place, the other at his spinal base, thus he could reason a priori as well as posteriori. No problem bothered him a bit, he made both head and tail of it, and if one brain found the pressure strong he passed a few ideas along. So wise was he, so wise and solemn, each thought just filled a spinal column, and if in error he was caught he had a saving after. If something slipped his forward mind, 'twas rescued by the one behind, since he could think without congestion upon both sides of every question. Oh, gaze upon this noble beast defunct 10 million years, at least. Well, it's been defunct for a lot longer than 10 million years. That's one thing that Berteleston Taylor got wrong, and, the other thing he got wrong, it didn't have 2 brains, but it certainly was an odd creature nonetheless. And that's what appeals to us about dinosaurs. They're big, they're scary, they were odd looking, and we tend to think of them as dumb, not just the little dumb but really dumb. And, of course, they're all extinct. They lived millions of years ago when the world was full of ferns and volcanoes. Why did dinosaurs fascinate us? We can't go out and see them, or can we? One of the reasons may be that children get so interested in dinosaurs, is they like to say their names. Think about it. Dinosaurs are about the only animals in our lives that we refer to by their scientific or Latinized names. We don't call a turkey Meleager scalopivo, but we don't call a Stegosaurus roofed lizard or a roofed reptile. That's what its name means. We call it a Stegosaurus. Incidentally, the name Stegosaurus refers to the plates on the back of the animal. Even the name dinosaurs, interesting to say, most people know that the name dinosaur comes from the Latin for terrible lizard and fearfully great reptile. Think about some of the names of other dinosaurs. Like Triceratops. Triceratops means 3-horned face. It was the big rhinoceros-like dinosaur that had 2 horns poking above each eye and 1 horn on its nose. And then there is Apatosaurus. Probably better known to many people as Brontosaurus. That's actually a dinosaur that was named Wise. Apatosaurus means deceptive reptile. Brontosaurus, on the other hand, means thunder reptile. That's a better name, but unfortunately we have to call it Apatosaurus. Then there's Diplodocus. One of the long-necked long-tailed dinosaurs, looks sort of like an elephant in the middle and snake on each end. Diplodocus means double being. It's a reference to the peculiar kind of vertebrae that Diplodocus has on its tail. Vertebrae that may have actually helped it rear up. Then there's Allosaurus. Allosaurus the meat eater, the big meat eater of the Jurassic period. Allosaurus means simply strange or other reptile. You wouldn't think it was strange if you saw it. You just think it was ferocious and you run the other way. The ones I like the best is called Unanididin. Unanididin was a great big duck-billed dinosaur of the Cretaceous times. Unanididin means big duck. And then there's the one I like perhaps the best of all, Pachycephalosaurus. It's a fun name to say. Kids love it. Pachycephalosaurus translates to fit-headed reptile. This was the dinosaur that had inches and inches of solid bone and tiny little brain. Velociraptor, star of Jurassic Park. Raptor means thief, velocity means swift. This is the swift thief. And the co-star of Jurassic Park, Tyrannosaurus rex, the king of tyrant reptiles. Most dinosaurs are Latinized in the masculine, but a couple of them are Latinized to the feminine, and for good reason, thanks to a well-known paleontologist named Jack Horner. Jack Horner has found an entire nesting ground of a dinosaur in Montana. He's found the nests, he's found the eggs, he's even found the babies. Appropriately enough, he named it Maiasaura. That's feminine and means good mother lizard. The only other feminine name for a dinosaur is Leelanasaura. The sort you probably haven't heard of. That's an Australian dinosaur, pretty small one, and it was named after a little girl named Lee Ellen Rich, whose parents, Tom and Patricia, named the little dinosaur. That's right. If you find a dinosaur you get to name it, and if you want to you can name it for your kid. What assumptions do we make about these creatures when we think about them? What we think about them? Well, probably most of us think dinosaurs were all huge, but not the Leelanasaura and not Velociraptor. We probably think many of them were swamp dwellers. That they were bizarre looking, dangerous, dumb, and of course we probably think of them as extinct. How accurate are these assumptions? Well, let's look at them a little bit more closely. Were all dinosaurs huge? The answer to that is, some were. Brachiosaurus, for instance, which means arm reptile, because it had such a long forelegs. If a Brachiosaurus were to stretch his neck the full length and stand up on its legs, as tall as it could, he could look directly into a 6-story high window. Its estimated weight, all the weights of dinosaurs are really difficult to determine with any great precision, is 75 tons. That's a big animal. Tyrannosaurus rex, everybody knows what a Tyrannosaurus rex looks like from Jurassic Park. T-Rex was about 40 feet long. Estimated weight anywhere from 5 to 7 times, females weighing a bit more than males. That would put it to be about the same size as an African elephant, terms of its weight, or 2Y Tyrannosaurus. By any measure T-Rex was huge. Stegosaurus, the dinosaur I talked about earlier, is estimated to weigh about 2.5 tons. That's about the same as white rhino. Triceratops, the 3-horned face which sort of looked like a rhino, weighed maybe up to 6 tons, again roughly twice the weight of modern rhino. But think about this: the largest mammal ever to walk the earth, and notice I said to walk the earth, was a creature named Parasauritherium found in Mongolia and is no longer alive. It was a creature of the Oligocene, some 20 million years ago. It weighed about 15 tons. That's roughly the same as what Diplodocus weighed, but the largest vertebrate ever to live, at least as far as we know, and, you're probably familiar with this, is the blue whale. They're alive today, and female blue whales can weigh up 200 tons, which is about 2 Brachiosaurus. Why some dinosaurs, by no means all, but some dinosaurs got to be as large as they did, to the real behemoth proportions, is really a mystery to a lot of paleontologists. But one thing is certain, they did really get to be that size, and so that demands some explanation. One possible reason is that they simply may have been able to consume food rapidly enough to grow fast enough, and they may have had enough pressure on them from predators, that being able to grow fast literally made them big enough that they never had to worry about predators. If you watch things like gazelles, for instance, which are modern average-sized mammals, they have a lot to worry about from lions and cheetahs. But if you watch elephants, they have very little to worry about with regard to predators. Even babies are protected by their parents, and their parents are simply so large, that size alone protects them from attack by these predators. So it may be that in the evolution between predator and prey of dinosaurs, that stimulated at least some of them to evolve larger sizes, because those larger sizes adapted to reduce the probability of predation. Remember, the predators were awfully large too. So yes, there were a lot of large dinosaurs, but consider this: there was a dinosaur named Compsognathus. These are the little creatures of several of the Jurassic Park films. Average weight estimated for Compsognathus was, maybe, 7 or 8 pounds. Cats usually weighed twice that much. Then there was a dinosaur named Ornitholestes. This means bird robber. This was a little predatory dinosaur of the Jurassic, estimated weight about 30 pounds. And speaking of little predatory dinosaurs, Velociraptor, unlike the big version of it that was shown in Jurassic Park, the actual Velociraptor only weighed about 33 pounds. Still, that's 33 pounds of animal you don't really want to get close to. Then there's a little dinosaur named Microraptor, that's found in Mongolia. A very bird-like dinosaur. Microraptors only weighed about 8 ounces. What about bizarre? Can we really put that label on the dinosaurs? Yeah, I think we probably can, at least for some of. I don't know of anything that reminds me of a Stegosaurus, except the Stegosaurus. That's pretty bizarre and related to Stegosaurus, as a group of animals, named Ankylosaurus. They looked like little armor tanks, except they weren't so little. The biggest of them got to be 20 feet long. They were so heavily covered with bone that even their eyelids had bone. That's a lot of bone. Then there are the long-necked dinosaurs Diplodocus, Brachiosaurus, the Apatosaurus with the long tails and long necks. Diplodocus maybe even had a tail that cracked like a whip. That's pretty bizarre. And the duck-billed dinosaurs, like Hadrosauridae and Maiasaura, these animals had big males with up to 2,000 teeth, which would grind plants better than any herbivore today. So, I guess, they qualify as being a bit bizarre. Truly one of the most bizarre was Therizinosaurus. Maybe you haven't heard of Therizinosaurus, since they haven't worked them into Jurassic Park yet. Therizinosaurus was a kind of bipedal dinosaur, that kind of looked like a duck with a pot belly. With a hand that was way too small for its body and with claws that were way too long for its hands. That dinosaur had claws that ranged in neighborhood of 1 meter long, and the animal itself stood about 6 meters tall. Anyone can tell it was a strange, waddling plant eater of Mongolia in the late Cretaceous time, nearly at the end of the time of the dinosaurs. That was a very strange looking creature. Were dinosaurs actually dangerous? Oh yes. Dinosaurs were really dangerous. It would have made no more sense to literally walk up to a herd of Apatosaurus and Hadrosauridae than it would be to wander around in a herd of American bison or Cape buffalo in Africa. You probably get trampled. And approaching a Utahraptor, over that matter, would make about as much sense as walking up and shaking paws with lion or a tiger. As for approaching a T-Rex, well, that's just plain nuts, it would eat you. Were dinosaurs really dumb? Interesting question. They appear to have been. They had pretty small brains. In fact, interestingly enough, there's a dinosaur called Camarasaurus that was once named Morosaurus, which was taken from Maron. It meant foolish lizard. Fortunately, that name didn't stick well. We can look at dinosaurs in a somewhat objective way, with regard to their potential intellect, by looking at something called encephalization quotient. Now, that's a fancy term for the fact that you can simply estimate the way the brain relative to the body mass. This is not the same as IQ. We don't sit dinosaurs in a room and have them solve puzzles. Now, the encephalization quotient is based only on the estimated volume of their brain relative to their mass of their bodies, and there is much variation among dinosaurs. Poor Stegosaurus, with a brain the size of a walnut, does not have the smallest encephalization quotient of dinosaurs. That honor goes to the long-necked sauropods, like Brachiosaurus, Apatosaurus and Diplodocus. Their pathetic little encephalization quotient is only 0.2. They had very, very little brain mass in relation to body weight. As for a Stegosaurus, well, it comes out to be about 3 times that big. Its cotton encephalization quotient is 0.6 and Ankylosaurus pretty much the same 0.55. As the T-Rex, well, it was a predator and predators are usually smarter than herbivores. Lions, for instance, are probably smarter than wildebeest. T-Rex encephalization quotient, depending on the brain used to measure, was somewhere between 1.0 and 1.9. And as for raptors, it had encephalization quotient quite comparable to modern birds around 5.8. One dinosaur, in that particular group, even had encephalization quotient slightly above 6, makes it pretty bright. How do I know this? Well, let's look at some familiar mammals and compare them. A squirrely, they're pretty smart. They figure out how to steal a snack from a hanging bird feeder in your backyard. They have encephalization quotients of about 1.1. A bottlenose dolphin, we all know that Flipper was smart, encephalization quotient of 5.6, slightly smaller than that of the largest encephalization quotient measured for a dinosaur. Chimpanzees are smart, but their encephalization quotients are about 2.5. So where are we in that scale? Human beings are anywhere from 7 to 7.5. We have about 37 times better brain than Apatosaurus, so it's not really accurate to say that all dinosaurs are dumb. Some of them were very comparable to modern animals, with regard to what the potential abilities to learn and to react would be. Now, all dinosaurs are extinct. We certainly know that there is no T-Rex, no Apatosaurus, no Brachiosaurus, no Triceratops. They're all gone. Part of the dinosaur mystique has always been their extinction. What caused it? Why are they all gone? Part of the reason they are so much fun is they were huge monsters, but all is well, because they're not here anymore. We can fantasize about them without worrying. But they may not be all gone. Modern birds, at least in the eyes of most evolutionary biologists, are dinosaurs. Just as cats are related to extinct saber-toothed cats and just as modern elephants are related to extinct mammoths and mastodons. Birds are related to extinct T-Rex and velociraptors. So if you look at it that way, there are about 10,000 species of dinosaurs that currently inhabit the world today, about double the number of existing mammal species. Birds taken together represent, however, far less anatomical and ecological diversity than we saw the full range of dinosaurs that once populated the Earth. Imagine a dense evolutionary bush with each of its branches representing the genealogy of one group of dinosaurs. Then imagine pruning that bush such that only one of those branches remains, all the others cut, all the others gone. That's the evolutionary history of dinosaurs, and that one remaining branch is that of the modern birds. Although long gone, dinosaurs stay interesting. The term dinomania was invented when Jurassic Park was released in 1993. People began collecting dinosaur models, going to see dinosaur movies, and the Discovery Channel kind of made a small industry of shows about dinosaurs. Probably most famous of which is the BBC series, Walking with Dinosaurs. What's more interesting, is that, dinosaurs have created their own celebrities among the scientists who study them. You have to understand there are not a lot of people who study dinosaurs. You have to have awfully big laboratory for that and a lot of money to excavate bones that weigh many tons. As of the number of people who actually spend their entire lives studying dinosaurs is fairly limited, but some of them are very bright and some of them are very articulate, and they've been seen repeatedly on the various shows about dinosaurs. Brought to you for the name Robert Bakker. Jack Horner, man who discovered the Maiasaura. Then there's Philip J. Currie, Canadian expert on T-Rex. Mark Norrell, who discovered first theropod embryo, and Michael Novacek, both from the American Museum of Natural History. Paul Sereno, who discovered supercroc, from University of Chicago, and Dale Russell, who was amongst first paleontologists to consider an extraterrestrial cause for the extinction of the dinosaurs. This is by no means all of them, but these scientists have appeared repeatedly on shows about dinosaurs. Okay, so we've established the dinosaurs were not all big. They were called dumb, bizarre, and are not all extinct, but what exactly were they? What actually was a dinosaur? I think it's a good idea to give you a few clues right now. Let's start by asking the question, what would a dinosaur remind you mostly of? Would dinosaur remind you of, say, a crocodile? What about a frog? Or a seagull? What about something like a bear? What kind of animal exists today most like a dinosaur? That's not such an easy question to answer. If dinosaurs remind you of a lot of crocodiles, maybe it's their physical appearance. They have, sadly, some of them a kind of crocodile-like face. What if you took the crocodile's body temperature, compared it with the body temperature of bear and the body temperature of a dinosaur? The dinosaur's body temperature was as warm as the bear's and considerably warmer than the crocodile. What if you watched the crocodile all day and hardly moved around at all, but, on the other hand, you watched a bear and it was pretty animated, and then, you watched a dinosaur? It would tend to behave like a crocodile, or would it tend to behave like a bear? And why a seagull? Would a dinosaur remind you at all of the seagull? Well, maybe if it was feathered. Some of them may have been. What about a frog? No. Probably not many dinosaurs would remind you of frogs. Let's just introduce a few basics. Now and then these will be revisited later. First, a dinosaur is a kind of animal called vertebrate, so are you. Vertebrate is a term that refers to the vertebral column of the bony column that makes up the basis for your skeleton. Now, things like cockroaches and lobsters are not vertebrates, because they don't have this kind of internal skeleton of bone. So, vertebrate is an animal of the skeleton of bone and dinosaurs are vertebrates. Humans are vertebrates and things like fish, reptiles and amphibians and birds are vertebrates. Now, what's a reptile? We will use the term reptile pretty loosely, because a reptile is an animal. We normally think of it as a crocodile, a snake, a lizard. But you will learn the dinosaurs were reptiles too, but they were a unique kind of reptile. They weren't the same as reptiles that are turtles, crocodiles, snakes or lizards. What makes a reptile in the modern sense is, that they have scales and claws. Some of them live birth, but most of them lay eggs. Those that do lay eggs and those that give live births are all reptiles. Just like all birds and mammals are capable of reproducing on land and outside of water. That's a big deal. Dinosaurs had scales, but not like reptiles. We have found skin impressions from dinosaurs and scales are not overlapping like the scales of modern reptiles, but are more like scutes with pimply patterns, a lot like alligator handbags. What is also very important, they were covered with feathers and none of the reptiles is covered with feathers. All modern reptiles, crocodiles, turtles, snakes and lizards are, what we call, cold-blooded. A more technical term for this is ectothermic. But dinosaurs may not have been ectothermic. So, if dinosaurs were reptiles, they were certainly different kinds of reptiles from crocodiles, snakes, lizards and turtles. That's a very big deal in understanding dinosaurs, but what made them different? What actually was a dinosaur? How would you define them? While, bear in mind, what it is that anatomists have to work with, and that's anatomy. Dinosaurs leave us a record of their bones, something that we call the fossil record. When we look at dinosaur fossils, when we look at their skeletons, we learn that they had erect posture, like your cat, or your dog, or a cow, and even your parrot. erect posture, which means that their legs were straight and under the body, much like us, mammals and birds, while reptiles have sprawling legs. Their legs come out from their sides and away from the body, like any lizard or crocodile. That makes them quite different from reptiles. Dinosaurs had unique hips and they had unique ankles, that made them capable of standing erect, supporting their body weight in the most efficient manner. Part of the reason for this is another characteristic the dinosaurs had, and that is the sacral vertebrae are often fused into a single structure in dinosaurs, called a sacrum. Dinosaurs are recognized as having 3 or more sacral vertebrae fused together, unlike most other reptiles, such as lizards and crocodiles, which have only 2. That is important, because hips hold up the body. That's really the fulcrum for the whole body. Dinosaurs had amazing hips. Hips much more similar to yours, incidentally, than they are of the hips of crocodiles or lizards. Now, just for the record, let's talk for a moment about what other kinds of vertebrates are, so that we hear these groups will know what we need. A vertebrate, as I said, an animal of the backbone. So what kinds of animals have those things? Well, there's one big group called fish, and fish came before all other kinds of vertebrates, and, so it is from fish that all other kinds of vertebrates eventually evolved. There is connection between fish and vertebrates that are land-dwelling. Then another kind of vertebrate group is called amphibians. Amphibians we typically think of as frogs and salamanders. What makes them different? While amphibians are tetrapods, that means they have 4 legs instead of going around with fins, which is what fish do in the water. Amphibians go about on land using actual legs with toes and they kind of walk. Now, amphibians, unlike reptiles, don't have scaly dry skin, they have skin that doesn't have scales or claws and it's very moist. This is because amphibians have to be in water at least part of the time. In fact, in order for them to reproduce they have to be able to put their eggs in some kind of aquatic situation. Sometimes it's in water, sometimes they're more innovative, like when frogs lay eggs in tropical bromeliads which are suspended up in the rainforest canopy. In any case, amphibians don't lay eggs with hard shells, and that makes them quite different from other things, like reptiles, mammals and birds. So, what about mammals? We are mammals, so you should know what that is. Most people think about mammals as being creatures with hair, some kind of fur covering. People also associate mammary glands with mammals. Mammals are unique, in that they suckle their young with milk. Dinosaurs didn't do that. Dinosaurs are not mammals. Keep remembering that dinosaurs were reptiles, but they were a unique kind of reptile. Now, we can't look in the fossil record and see defined hair and mammary glands. We can only look at skeletons, so the other thing you should know is that mammals have different kinds of skeletons from dinosaurs. We see very many differences between mammalian skeleton and a dinosaur skeleton, but one of the characteristics mammals do have, which may be something shared with dinosaurs, is that mammals are very active. Mammals are warm-blooded, or, as we call it, endothermic. So they have very high metabolisms. They run and scurry around, and that's a characteristic that dinosaurs may have shared. What about birds? All birds are like mammals in the following way: they're also endothermic, they have high metabolisms, they're covered with feathers instead of hair, but it amounts to the same thing. Fur keeps you warm and feathers keep you warm, and birds are additionally unique in that they can fly. Some of their feathers are adapted to allow them to fly by forming wings, so birds and mammals both have characteristics of high activity levels, and they are very upright in their postures. Rather like dinosaurs, so dinosaurs in many respects have much more in common with birds and mammals, than they do with traditional reptiles, even though dinosaurs are reptiles. But, what you have to consider is dinosaurs were unique. They were a unique group of animals. They don't really fit in any of the standard groups of vertebrates, and in fact birds really A lot of dinosaurs lived at the time called the Mesozoic era. The Mesozoic era began 248 million years ago, that seems like a long time ago, and ended 65 million years ago. It's divided into 3 periods based on patterns in the fossil record. The first of those periods is called the Triassic. The second is called the Jurassic. Yes, you've heard of Jurassic Park, and the third is called the Cretaceous. Dinosaurs really flourished during the Jurassic and Cretaceous, but they evolved in Triassic. Dinosaurs were common for at least 160 million years. They were on Earth far longer than humans. Again, at the earliest, humans evolved around 3.5 million years ago. They weren't quite human men, but they were starting, and Homo sapiens, our species, have arguably been around for at most about 500,000 or more years. So, if you look at hominids, the group to which humans belong, the human family tree, we've been around for a grand total of about 0.77% of Earth's history. We are real newcomers. 95% of Earth's history happened prior to the dinosaurs. So this is the geologic time that we're dealing with, the Mesozoic era.